Okay, so arithmetic sequences. So what makes an arithmetic sequence? A common difference, right? So in this one, 1, 3, 5, 7, 9, 11, each one is going up by 2. Easy, okay. So it's just a formula. So let's just go through the formula here, and we can do this. All right. Definitions. D, common difference. N, number of terms, right? So if you're looking for the 107th term, N is 107. T1, whatever the first term is, and Tn is whatever the nth term is, right? So if we're looking for the 107th term, that's what Tn will be. Okay, so let's do an example. So you have one, where's the example? Flip page, I think? Or no? Okay. So let's look at this example here. Why do I already have this on here? Oh, well. I must have written on my notes. No big deal. Okay. Let me just get rid of this, guys. All right, so look at the question. Johnny's a keen student, right? This is all of you guys, right? He's going to study. This is an interesting concept. So the first day that he comes out of class, how much does he study for? Read on the example then. Example 1, Johnny is a very keen student. During each school night of the year, he spends 1.5 more minutes every night. So first night, next night, 1.5 more minutes. Next night, another minute and a half. Next night, another minute and a half. Whew. Keen. Okay. So what we want to do, on the 73rd day of the school year, he did homework for how long? 152 minutes. So 73, way down the line, number 73, the 73rd day, he did 152 minutes. What we want to find out is that first day, how much homework did he do? How much studying did he do? So what are we looking for? What's the thing we're looking for if we're looking for the first day? We're looking for T1. Okay. So what we got here is we got a bunch of numbers, right? Well, we have to put letters to these numbers, because if we put letters to these numbers, we can plug them into the formula, can't we? Yeah? Okay. So what did we say we're looking for? We're looking for T1. That's what we're looking for. We don't have a clue yet what it is. Okay. What's that? 1.5 minutes. D. Is it the common difference? 1.5 every single time? So this guy right here, that 1.5 minutes is D. That's not bad. We have 4 unknowns. We already have 2 of them. Well, one we're going to look for. Now what's what? What's that 73rd school day? The nth. Is that the one we're looking for? Is that the nth day? Is that the nth term? That's the number of it. So this 73 right there, that 73 is the n. So by a process of elimination, what's the 152? What's this 152 minutes? No, we're looking for T1. Tn. Okay. Now think about this for a minute. We're talking basically that's the Tn, but really which term is that? What term is that? What did we just say n was? 73. So what is the 73rd term? Like if we had a series of numbers, a sequence of numbers, bang, 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 bang. We get to the 73rd one. How much is it? 152. Does that make sense? Like it's not, the term is not 73. The answer is not equal to 73. It's the 73rd term is 152, right? What we're trying to do is we're trying to find the first one. And then we add 1.5 to each. Now, could you do this backwards? Could you take 152 and subtract 1.5, and subtract 1.5, and subtract 1.5, and do that 73 times? Would that be a waste of your time and mine? Immensely. Right, so we can use a formula. Okay, what's the formula? Read it to me. Is it plus? There it is. Formula. Big deal. Welcome to pre-cal. Formula-driven math. Okay. Now there's 1, 2, 3, 4 unknowns in there. We know 3 of them. Can we solve? That's algebra. Okay. What is the 73rd term? Okay, now, the biggest mistake you guys will make is you're going to put that there instead. Right? That is not the number that goes there. What is the 73rd term? 152. Okay. Do you see how that could be a common mistake? Yeah. So 152 equals, what's the first term? We don't know. What's n? 73. What's d? 1.5. Now it's just a matter of math. Let's do some math. Now, for this class, you'll need a calculator. TI-83s are okay. You really don't need them. They're nice when you get to the graphing part. Just a basic calculator, those sharp ones that you have right there. Was that a 531? It's a 501. 531 or a 531. Any of those are really good. If you lose your calculator or miss it during the day or something, I have a bunch up there in the corner. You just got to give me something as collateral. Cell phone, wallet, a puppy. I don't care. Anything. Okay. Who needs a calculator? Come get one. Put something of value in the box. Come get a calculator right there. Just put something of value in the box. Do not take a calculator without giving me something of value. Yeah, shoe's fine. As long as your feet don't sink. Okay. Now, how do we do the math? What do we do? What do we do first? Bracket. So we got to go 73 subtract 1, which is 72. And then what are you going to do? Times it by 1.5. So do that. Do the math. 152 equals T1 plus, what is that? 108, is that what it is? 108. Okay. Now what do you do with the positive 108? Subtract it from both sides, right? That's basic algebra. If you add 108 to this side, subtract it from both sides. So what is that? Here, I'll do the math here just so you can see me doing it. 108, subtract 108. Those are gone. So what's the first term? 44. 44 what? Okay, minutes. Now think about that for a minute. So on the first day of school, he walks out of class, he goes home, and what's his name again? What's his name? Johnny. Johnny. Johnny's such a keen student. How much studying or homework does Johnny do that first night? 44 minutes. That is the first term. On the first night, he does 44 minutes. Then every night after that, how much more homework does he do? 1.5 minutes. So then, after 73 days of school, 73, right? How many minutes did he actually study for? 152. Right? Does that make sense? Like the sequence? Okay. Nope. Okay. Not bad. Easy, I think, so far. You look lost. Now, if the pattern continues, how much homework will Johnny have on the last night of the school year? Oh my. Last night of the school year. So, day 180. What is that 180? That's n, because there's 180 days. Okay, so let's do the same thing again, but let's define our variables. You should always get in the habit of doing that. So this is part B. So we said n was how much? 180. What's d? We know this already. What's the common difference? How much more each day? 1.5. Now here's the difference. We don't know how much, we're looking for Tn, aren't we? We're trying to find out how much homework he does on that 180th day. That's what we're looking for. Now here's the thing. Do we know what T1 is now? 44. Now, here's the thing. If you screw up T1 on the previous question, is your answer going to be wrong now? Yeah, of course it is. And when I mark a test, right, when we get to test time, and let's say you did that on a test, you screwed it up and let's say you got 43 instead of 44. But then you did the next part of the question right. Do I give you follow-through marks? Yes, it's just you completed the question correctly, you just had the wrong number. It was a carry-through error. So if a question like that was maybe out of 3, you might get 2.5. Okay? It's about the process that's involved. Sometimes, even if you get the wrong answer, you can still get a bunch of marks. Okay? Does that make sense? So make sure that's clear. Okay. So 1, 2, 3, 4. We have 4 things. We need to solve it. So what are we going to write down next? Write down the formula, the equation. Yeah. Get in the habit of doing this. I'm showing you the way I want you to do your work. Tn equals T1 plus n minus 1 d. You don't even have to memorize that formula. You get it. Will you memorize it by the end of it? Oh, yeah. You'll be using it so much. Okay, now, we know what T1 is, we know what N is, we know what D is. How do we write this at the beginning so it makes sense to us? What are we looking for here? What's this thing we're looking hard for here? Yeah, Tn, but what is N in this case? 180. So we are technically, are we looking for the 180th term? Yeah, that's what we're looking for. I want to know, after 180 days, how much homework he's doing. So that's the 180th term. Yep. No, because we know what N is. What's N? Yeah, you're telling me I'm looking for the 180th term. This is how you do it. Like if you put T in there, that's fine, but you know you're looking for the 180th term. What's T1? 44. What is N again? 180. Hey, if you ever forget, did you just write it there? Yeah, that's N. Please note, that N and that N and that N are all the same. Minus 1 times what's D? 1.5. Okay, so what is the 180th term? So what do you do for math here? What's the order? Yeah, 180 minus 1, which is 179, times that by 1.5, equals, and then plus 44. Don't forget to press equals between that. What do you get? 312.5 minutes. Oh my goodness. Man, how many hours is that? Heck of a lot. That's way too much time. Do I expect you to study that much? 5 hours a night. That's a little much. And if he was studying 5 hours a night, he'd be teaching this course. Okay. Okay, example number 2. Flip page. Flip page. You okay? Don't bang your elbow, man. It's dangerous. You'll hurt yourself. Okay. Whoa! Remind me to save this properly when we're done. I opened up the wrong file. That's fine. I opened up one that was already... Okay. Basic example. First term of an arithmetic sequence is what? Okay, so what do we know? Already, what do we know? T1. So if you know that right away, should you write it down immediately? Yeah, do it. Then you won't make any more mistakes, you'll make less mistakes because you already know that. The nth term. Right? We don't know what number it is. Somewhere way out in the wild blue yonder, that term, how much is it? So we know that the nth term is how much? 309. We don't know what n is yet, do we? And, oh, that one's kind of a giveaway. The common difference is 3, so what's D? 3. Ooh, that's tough. So what are we looking for? We're looking, like NA. Looking for N. Here's the deal. When you do these questions, there's 4 unknowns. Will you always be given 3? Yeah. Could you do it otherwise? No. Okay, what should we do now? Write down the formula, the equation. Okay, so Tn equals T1 plus n minus 1 to the D. There it is. You fill in the next line. Let's see if you get it right. Fill in the next line. Let's see if you make the mistake that I think you may make. Fill in the next line. You got the next line filled in? Okay. This guy right here. This is the one, this first one is the one that's going to screw you up. What did you put right there? 309. Don't be embarrassed. Did anybody else put something else? What'd you put? Oh, okay, so you did this. Hang on. Don't write this down. So you did this, right? You put down the 300. Basically what you're telling me is that's the 309th term. No, we don't know what n is. We're trying to figure out what the term is. What is that term right there? It is 309. Okay. It's a common mistake to make. So right here goes 309. That's the number. That is whatever term out in the wild blue yonder is. It's 309. We just don't know what place it's at, right? If we could actually do this, right? Oh my goodness. We could go 12, and then we just keep adding 3. And make a big old list until we hit 309, and then figure out what term that is. Way too much work, right? This is a way to calculate it mathematically. What's the first term? 12. What's n? No clue. What's d? What is it? 3. Oh, I haven't even seen this math yet. Variables in the middle. Put some brackets around it. Any clue what to do? If I had $100 in my pocket, and I decided to give you all in equal amounts, what do I do with that money? What's the property called? You learned it in grade 10. Learned it in grade 9, actually. I handed out the papers. What did I do? I distributed them. Oh, do you remember the distributive property? Ooh. This 3 gets distributed where? Everything in there. Do you remember this now? Oh, yeah. Looks backwards to the way you might have done it, right? You might have had a number in front with a binomial or a trinomial in the middle, and then you distribute that number. Do you remember that? You got to do the same thing here. Okay, so 309 equals 12 plus, what's 3 times n? 3n? What is 3 times negative 1? 3 times negative 1? 3 times negative 1. Distributive property means multiplication. Multiplication. Do you remember that now, though? Remember from the dim past? Oh, you're there, yes. Okay, now what do you do? 309 equals, what's 12 minus 3? 12 minus 3. 9? Guys, this is an interactive math class. You better be talking when I'm asking. Don't just sit there like a bunch of lumps. Now what do you do? Minus the 9 from both sides. You know this. You know your basic math, right? Algebra. So minus 9 from both sides. Here, I'll put the work in just so you can see. I don't normally put the work in. Eventually, we'll just get rid of this after a while. So 300 equals 3n. Now what do you do? Divide both sides by 3. N equals 100. But what does that mean? Big deal. You can calculate a number. What does it mean? What's it mean? What's n? Okay, the 100th place. And if we counted these out, right, we start at 12, and we add 3 every time. Once we get to the 100th spot, what is the actual number in that 100th spot? 309, right? So if we actually did this out, we start at 12, and then we go 15, 18, 21, 24. By the time we get to the 100th spot, that number there is 309. Does that make sense? Just a way to calculate big old sequences, right? Because normally you, like in grade 9 when we did this, right? You actually remember you just wrote out the sequences? Like we did numbers, right? You just keep writing them out and you figure out what 10 is or 11. This is the way to figure out big suckers. Oops. Yeah. What do you think? Not bad? Easy? Yeah? You'll understand this more once you actually get doing the examples where they give you one of those, they'll give you 3 of the 4. Okay, let's do the last one here. We'll be done and then you'll have the rest of the class and all of tomorrow is a work class. Oh, there's 2 examples here. I think, isn't there? Yeah. Ooh, roller coasters. I love roller coasters. Why do people like roller coasters, by the way? Well, why? What's fun about a roller coaster? The adrenaline, getting scared, right? Why do people watch scary movies? Because they're stupid, yeah, man. All right, people like it because they like to be scared. Come on. Board is all over the place. Okay, let's go back to the roller coaster picture. Okay, so I think the hardest thing you'll find with this stuff once you get rolling is deciphering all the words to math, right? Word problems are always one of those things students just struggle with, right? Because you got to take all this stuff on there, right? You got to weed through it until you find the stuff that's really, really important. Because once you can plug it into a formula, you can do the math. That's the easy part. The hard part is deciphering. So the roller coaster fair has a 15-person lineup when it opens at noon. Bang, it opens at noon. How many people are in line? 15. So what do you think that 15 is? Good choice, right? There's 15 people in line. Right at noon, there's 15 people in line. Okay, so let's just put this down here. So T1 you think is 15. We can figure this out, right? Because we should have 3 out of the 4 when we're finally done, if we did it right. As the fair gets busier, right, and you've been to a fair before, the lineups increase, right? Every hour, how much does the line increase by? 6. Right there. It increases by 6 people per hour. So what do you think that 6 is? So what is it? D, right? So D is probably 6. Spooky. I'll give you all this stuff in a minute. Okay, and the fair closes at 11. Okay, so what we want to know is we want to know the number of people standing in line at 4 o'clock, at 5 o'clock, and at 6 o'clock. Sorry. Now, this is where it gets a little trickier because you're kind of trying to decipher all this information. Okay. So let's write down what we know. So we're doing A here. Show the number of people standing in line at 4, 5, and 6. So let's use the formula. Now guys, could we figure this out manually, really quite easily? Right? What's how many people on the line at 12? Could we just keep adding 6 until we get the numbers? So we can check our answer, but we're going to do it mathematically. Right? We're going to do it with the formula. Let's figure out at 4 o'clock. Let's figure out how many people, number of people at 4 o'clock. Right, let's find that out. I don't know if you understand that. Number at 4 o'clock. I'm just using some shorthand. Number at 4 o'clock. So, T1 and D, we're looking for Tn, aren't we? Isn't that what we're looking for? The number of people? What the heck is N? So, you think N is 4. Why did you think it was 4? Just tell me why you thought it was 4. No, it's 4 o'clock, isn't it? Let's check something out here. What time does it open at? What comes after 12? Don't say 13. We're going back to the other counting system first. 1 o'clock? 2 o'clock? 3 o'clock? 4 o'clock. Okay, there's 4 o'clock. How many numbers are there? Oh, what's N? 5. So 4 o'clock, right, is actually the, which term? The 5th term, right? 4 o'clock is actually the 5th term. Now, if you had that on the test, would some of you make that mistake? Probably all of you would have made that mistake until I've told you now. And now you're going to make that mistake on a test? No, of course not. So N in this case is not 4, it is, what is it? 5 o'clock. Oh, cool. Now look what we got. 1, 2, 3, 4. We got 4 things here, 1 unknown. Can we solve for it? Yes, so what do we need to write down next? The formula. Yep. We'll get to that one in a sec. There are 3 separate questions, right? Who asked that? There are 3 separate questions, 4, 5, and 6. Now, once we get 4, can we figure out 5 and 6 pretty easy? What are we going to add to it each time? 6, right? We're just going to add 6 to it, right? That's the easiest way, because you show me mathematically how to get 1, then you can do the rest that way. Okay, so what is it? Tn equals T1 plus n minus 1 to the d. So let's fill in what we know. Now, here, which term are we looking for? Yes, but what is Tn? T to the... We're looking for the 5th term, aren't we? The 5th term is actually, what time? 4 o'clock. Okay, what's the first term? 15 plus what's n? 5 minus 1, what's D? 6. 5 minus 1, 4 times 6, 24 plus 15. 24 plus 15. We're doing mental math. That's what 39. So the fifth term is how much? 39. So at 4 o'clock, which is the fifth term, how many people are waiting in line? 39 people. Okay? Make sense? So then if you wanted to, at 5 o'clock, how do we figure out 5 o'clock? Add 6 to that. What do you get? 39 plus 6 equals 45. What about 6 o'clock? Add 6 more. So 45 plus 6 equals 51. Cool. I should... Oh, you still got lots of room in this question. I didn't give myself much room in this question, did I? Let me just move this down so I have more room here. Right. Does that make sense? Now this is a two-parter, right? What's part B ask? Okay, so 1 hour before the fair closes. 1 hour before the fair closes. We want to know how many people are standing in line. What time does the fair close at? 11. So what's 1 hour before 11? It's 10 o'clock. Now careful! Careful! It's 10 o'clock. But which term is that? The 11th term, right? Because we started at noon, right? Noon, right? Noon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 11th term. Okay. Do you see how you can make that mistake? If you made it in the first part of the question, you'll probably make it in the second part of the question. Okay. So let's write that down. So, scroll this down here. We are looking for, what did we say N was? 11, is that correct? Okay. What is T1? 15. What is D? 6. And we are looking for which term? Tn, or the 11th term, right? We want to find out at 10 o'clock how many people are standing in that line. So the 11th term. Yep. Yes, you could. Just by continuing adding them up? Yeah, sure, why not? The thing is, it would be accepted if you did it that way by adding everything, as long as you did the work for this first one. Because that's what I want to see. I mean, I could easily fix this. I could say a day and a half from now, right? Now, you want to do that manually? No, of course not, right? But because this isn't reasonable. So a question like this, you can actually check your answer quite easily because you can actually physically count out the numbers. I got no problem with that. Okay, so Tn equals, what am I doing now? Formula, thank you. Please, guys, get in the habit of doing this. It's going to be for the rest of the semester. You need to write down the formula because often what happens is, seeing so many students do this, they write down the wrong formula. Doing all the work, they got it all wrong. Okay, so we're looking for the 11th term. What's the first one again? 15. You don't even have to think, isn't it? Just written right there, right? That's why we write that stuff out. So you don't even have to think, you just got to fill in numbers. What's N? 11. What's D? Now I bet you we can do this in our heads. What's 11 minus 1? 10. 10 times 6. 60 plus 15. 75. So at what time again is this? Is that 11 o'clock? Oh, yeah, it's 10 o'clock. 1 hour before close. It's the 11th term. At 10 o'clock, how many people are standing in line? 75 people. Do amusement parks want to know this stuff? Yeah, because then they have to stop letting people into line at a certain time so that they can allow all those people to get through the line, right? So if a ride only handles so many per hour, right, they might actually have to close the ride earlier than that, right? They do all this stuff, right? They actually forecast progressive numbers through it. Now, they do it all on computers nowadays, right? We're actually doing it manually. Yeah, what do you think? Easy, hard, difficult? What do you... Not bad? Of course, you might find it difficult because you missed the first part. Okay. Last question. Got 10 minutes. Last question. Normally a lesson will take anywhere from 15 minutes to half an hour. A normal lesson, just so you know. And then you have a whole other work class. That doesn't mean you immediately stop and not do it. I would do some at home before the work class because you don't want it to leave your brain. Okay, 3 consecutive terms. What does consecutive mean? One after another. So 1, 2, 3. Are those consecutive?
Yes.
Okay. 2, 4, 6. Are those consecutive? Yes, they are. And what's the common difference in that case? 2, right? Consecutive numbers can jump, right? 5, 10, 15, 20. Are those consecutive? Yeah, they're going up by 5. Consecutive means just one after each other. Okay. So the terms are what? What's the first term? What's the second term? What's the third term? Okay, they're different, right? They're not just numbers, they're polynomials. Okay, here's the thing. If they're consecutive, what do we know about them? Of those 4 things that we talked about already, T1, Tn, N, and D, right? Of those 4 things, if they're consecutive, what should they have? Should have one of those. They should have what? And in particularly in a difference, should they have the same difference between them?
Yeah.
Should the difference between these two be exactly the same difference as between these two?
Yeah.
Yeah. Between 2 and 1 and 3 and 2. They should be the same. Is that correct? Okay. And should those differences be exactly the same? Sure. Well, let's do this. What's the third term? 4x plus 5. And what are we going to subtract from it? No, careful. Think about this again. Difference between 2 and 1 is the same difference between 3 and 2. Okay, well let me here. Stop. Let me give you a different set of numbers. Let's try it this way. 1, 3, 5. Okay? Are those consecutive? Okay. 5 minus what? No, what's the one in front of it? What's the one in front of it? 3. What is it going to be equal to? 3 minus 1. Is that correct? The difference between 3 and 2 is exactly the same as the difference between 2 and 1. Is that correct? 3 and 2, 2 and 1. Are they both 2s? Okay. Apply that same logic to this. This is the first term. This is the second term. This is the third term. So 4x minus 5, which is the third term? Minus 3x. What is it going to be equal to? 3x minus x. Because basically what we're saying is the third term minus the second term is exactly the same as the second term minus the first. It's a common difference. It has to be the same. Well, what do you have on the board there now? No, because there's no squares in it. Which we're going to get to yet. You'll be able to solve those. Is it just a bunch of x's and numbers and a big old polynomial, an ugly polynomial equation, right? Can you solve for this? Of course you can solve for x. How do you solve for x? You what, sorry? Yeah, get the x's to one side. The key to solving an equation is to get the variable by itself. Right, let's try that one more time as a class. Hey, the key to solving an equation is to get the variable by itself. And that's the basis of all algebra. That's the basis of everything we do in this class, no matter whether it's a quadratic, a linear, any of that stuff coming up. You have to get x by itself. If you get x by itself, you can do wonders. Where do you want to bring? You want to bring everything over to the left or the right? Okay, let's bring the x's to the left. Okay, so to rearrange this, okay, let's simplify this a bit first. What's 4x minus 3x? X plus 5 equals 3x minus 1. Is that correct? Just combine like terms. CLT, combine like terms. What do you want to do now? What do you want to do? You want to put the x's to the other side? Yeah, it's a common way to do that. A lot of you learned to always bring the x's to the left, didn't you? Yeah. You'll learn as you go along. Sometimes it's not always the nicest way of doing stuff. If we take the x's to this side, they remain positive. If we bring the x's to the left side, you're going to have a negative in there, right? It's an extra step. So if we subtract x from this side, we're going to subtract x from this side. Let's do a double step in here. How do we get rid of the positive 1? Add 1. So what do we do over here? Add 1. All right. This is something you're going to learn now in grade 12 or 11 too. You're going to start combining steps, make your life easier, make it faster. These are gone. These are gone. So what are you left with? 6 equals, what's 3x minus x? 2x. Now what do you do? Divide by 2, divide by 2. X equals what? 3. You're done, right? You go writing your unicorn underneath the rainbows. Is that right? You're done? Have you answered the question? No. What's the question? Well, I guess you actually have. Determine the value of X. What is X? 3. Okay, so let's figure out what the terms are, though. So the first term, first, second, this will be the second part of this question. First term is what? 3. Okay. What is the second term? 3x. And what's X? 3. What's 3 times 3? 9. Okay. Now, let's take a guess. What is this going up by the way? What did it go up by? Common difference. Subtract. 6. So the next one should be 15, if we did it correctly. Let's double check. Okay, so there's the third term. What's 4 times 3? Plus 5? Did we screw up? Where did we screw up? Hang on. Where did we screw up? Oh! Where did we screw up here? 3x. Oh! Brilliant. Oh, my goodness. First math teacher ever. Where did I screw up? Not 3x minus 1, it's 3x minus x. Why did I put a 1 there? I know exactly why I put a 1 there. It's the first term, right? I was thinking, oh, stupid me. Okay, sorry guys, sorry. Ooh, bad mistake. Well, yeah, I did that on purpose. Do you believe that? No, oh, please, I screwed it up royally. Leave me alone. All right, let's fix this. So what is this again? So x plus 5 equals 2x, is that correct? Yeah, bring that to the other side. So 5 equals x. So that was way easier, wasn't it? Oh, I screwed that up big time. But it's interesting, though. Even though I made the mistake, it's interesting when we got to the end. Did I realize I made a mistake someplace? How did I realize that I made a mistake someplace? Because it didn't work, did it? I don't know. Yeah, that's kind of cool. I know it was not deliberate, by the way. I really screwed that up. Sometimes I do that. So first, second, third. Let's do this again. Okay, what's the first term? 5. What's the second term? Times by 3? 15. Now the next one, if it goes up by 10, should be 25. Let's double check. 4 times 5? 20 plus 5? Did we do it right? Awesome. Right. Something you're going to have to get used to in grade 11 is, the bell's going to go right there. Something you're going to have to get used to in grade 11 is when you do your work, you're going to have to verify your stuff, and you'll get that as you go along. Okay, so what we'll do tomorrow is we'll start on the questions, and if you, well, I haven't given you any, so guess what, there's no homework. We'll do it in class tomorrow. There'll be enough time. I'll give you specific questions. I'll look them over tonight and do it for you.